Thank you very much. It's a great pleasure to be here. It's afternoon, the second day, late afternoon. I'm very fortunate that the previous session was a bit more activity and enjoyment, so hopefully you can tolerate this one. I'm going to talk to you about iSee, which is a technology that I have been doing research on for about 5 or 6 years now, and it's now close to being a commercial product. It is, in a sense, a video conferencing application, and you say, you've seen all of these video conferencing applications. Would anybody really do research on new yet another video conferencing application? And that would be a fair statement, but what was my passion was that I wanted to remove only one limitation in video conferencing, and that limitation is the number of people who can participate. So I believe that the future of internet is when people use internet as a meeting place, not just one or two, but actually in crowds. And of course, you can have a video conference today, but there is always some limitations in terms of how many people you can engage in a video conferencing. Some of these limitations are technical, because if you have a video conference and there are 5 people in it or 10 people in it, you have to send a video and audio of each participant to everybody else. That really means that if you have 5 people, you need to, so in the order of 5 to the power of 2, 25 video and audio streams sent through the network. With 5 is okay, but if you had 20, then it's 400. 400 video streams and audio streams. And okay, maybe you have a very good NBN network and can handle 400 videos, but it's very easy to beat any network. Just make it 30, becomes 900. Make it 100, becomes 10,000. So the capacity grows as a square of number of participants in a true interactive video conferencing. And therefore, most video conferencing application is limited to few, maybe a maximum 10, 12, for this reason. It's just fundamental technical reason. The second reason, which I think may be more important for you, is that actually cognitively, this is one of the video conferencing that you see, a number of video tiles in front of you. How many video streams you can interact with like that? I mean, if there were 100 people in this environment, it's very hard for a human to interact with 100 different video streams and audio streams. We have no problem mingling with a crowd of 100. So that's not our problem. The problem is with technology. So what we tried to do in iSee was try to actually recreate the real characteristics of a mingling in a crowd using the combination of concept of video conferencing and virtual environments. So you have maybe seen Second Life or other virtual environments. In those virtual environments, avatars look like a graphics representation of you. And sometimes you want that. You want you to be like an alien with tentacles. That's for purpose that you want. But we wanted to actually turn the avatars into your real video and audio, real-time video and audio. So at the risk, and it is a great risk, trying to do something, a research prototype demonstrating live. I just want to run iSee so to show it to you. And I have asked few people, really the power of iSee will be shown when you have a large number of people in the environment. If I can ask. Okay, so first of all, I am in an environment. This is like a room, and in this room, I look like this. This is a webcam. I can turn it around so it sees you, all right? And I am like a floating board in this environment, and so are the others. So I'm not looking at it from my first-person perspective, and these are the other people in the environment. There may be audio here. Guys, can you hear me?
Yes, we can hear you.
Yeah, so now we have the audio. Guys, can I ask you to talk simultaneously so we know that there is audio?
Hey, we'll have a. Hey there, Alan. How was your weekend?
All right, so notice this. Thank you. Notice this, that I cannot control them. So if they were students, they could walk out of the lecture or actually whisper to each other, making fun of me, which is exactly what we want to do. They can move, they can rotate, they can change their perspective, they can form their own groups, they can go to the other corner of the room. So I can do the same thing. I can, if I don't like the company of these fellows, I can walk here. And I can see them in that corner having a conversation. If they're having a conversation, I am peripherally aware of their conversation because the audio is spatial. It propagates through the environment as it should. You don't see it because you don't have a headset, so you're not in front of a computer. But actually, it comes from the right direction at the right distance. So if they were far away, I would hear them from a far distance. If they were having a conversation, if this was a student group, for example, having a workshop, I could hear on that table a conversation peripherally. If I could focus on it and walk to them. Guys, so let me just say, Graham, you're in Sydney now, are you?
Yeah.
All right. And
That's correct, yes.
Abu, where are you now?
I'm in Wollongong.
Okay, Abu is in our university, Wollongong. Amir, you're in Miranda? Or?
Yes, I am.
All right, so Amir is there, and there is Alan is there at the back there, and there are a few others. Warren is there. Warren is the CEO of our Smart Services. Okay, let me walk to Warren. Warren, are you doing something else?
Yeah, no, I'm here, I'm watching. Very much paying attention.
Very much paying attention. Thank you very much. Anyway, so I think what other thing that you can see in the environment, we can actually place PowerPoints on the walls, images. This is image of Anthony, I think. Yeah, that's the image of Anthony in the wall. They can actually upload the PowerPoint. We can go through the PowerPoint presentation. You can do the usual thing that you can do in video collaboration, but there is no limit on the numbers. So you can have this conference there. Now, you can have hundreds of people. The limit really is only physiological. How many people you can interact with at the same time, and there is always a limit. And as you can see, humans actually quickly form groups. When you have a crowded conversation, you may start at one person talking, but quickly you create lots of groups, and there will be multiple simultaneous conversations. That is something that cannot do any existing video conferencing. Multiple simultaneous conversations, groups happening at the same time. What are these guys doing? Okay. Guys, maybe I should, before we embarrass ourselves, I just sign off. All right? Thank you very much for your participation.
Okay.
No worries.
Thank you.
Now, one thing that I want to say is that, before I finish and hand over to Anthony, is that this is, of course, was a research prototype. We are now building, I think, in Australia, the first who are building such a thing. And it works on a normal laptop, no special hardware required. It actually is very smart because, of course I say it's smart, because remember I said that there is an n squared problem, there is a square of number of video streams. That doesn't happen here because we actually, at each moment in time, we calculate who you are looking at and who you could hear. Your visual range and oral range. And we only deliver that video and that audio which is relevant to you. So it doesn't matter if there are hundreds of people in the environment. With any kind of bandwidth, even 3G bandwidth, you can actually run this. So it doesn't have to be a student which has a huge amount of bandwidth to be able to run the application. I probably stop here, but if you guys are interested to help us improve this, maybe trialing it or doing some usability testing, maybe let some of your students to just play with it. We would really be appreciative of that. And I let you do it. I don't know how to. You need to maybe close this one. It's outside the space. You can also try iSee here. We have a demonstration here set up.
Thanks, Farzad. So this is actually a slightly different topic, but there's also a similar story about this coming from a research project. I'm going to present today our work on interactive surfaces. It started off as a research project based at Sydney Uni, funded by Smart Services, looking at how to design surface computing to be really natural to use by a wide range of age groups, but also looking at how we can make it all connected. So not necessarily thinking about linking different sites together, but also connecting things in the same room, so making it really easy to transfer information between devices or across the world if necessary. So interactive surfaces are beginning to appear in many contexts. We're certainly seeing interactive whiteboards everywhere now, and they're used a lot in education. We can also use interactive projectors, and we can also position those so that they're projecting onto tables, and that means that we can have a group of students around the workspace working together on a shared problem. At the same time, we've also got multi-touch table technology, which is useful in that it allows multiple learners to engage collaboratively around the workspace. There aren't really any restrictions on the number of people touching the device, so everyone could be working together. So there's going to be an explosion in the software available for these devices, but they're typically running on their own platforms. So whichever hardware manufacturer makes the table or the whiteboard will make their own software that goes with that. What we want to achieve is a platform that runs across all of these, and by platform I mean software, and it connects all of these together. So it could be as simple as throwing information off the edge of one display and having it appear on another. So in the case of a connected classroom, you could have, say, 4 multi-touch tables and some interactive projectors on the wall. The teacher can flick information off the edge to present it on any display during the session. And groups could be working individually at those devices and then bringing it all together at the end of the session on the large wall display at the front of the room. So the research behind this was looking at how we could connect all of this together and what would that enable. So if we were to make a platform that ran across everything, what kinds of applications would be possible? So this is an example of a connected room running the Cruiser platform, which is made up of multi-touch surfaces, projected tables. So there's a regular table with a projector shining down on it, which is the one on the left where we've got 3 participants there. We're also using a conventional interactive whiteboard, and there's also a wall projector at the front of the room. The information can just be flicked between any of these devices, including the tablet devices that they have in the session. So it's important that in these kinds of environments, people can bring their own devices into the session, bringing the information they may have collected previously. They can share and discuss that at the shared workspace, and they can also create new content while they're there. So they could be brainstorming about the information presented. So Cruiser is hardware agnostic, and by that we mean you can run it on whatever touch or pen hardware you like. So that could be a multi-touch table or an interactive whiteboard. You could also run it on a conventional computer if you wanted to. So you could be connecting into a session that's happening while you're on the road, and you could see what's happening in another location on their interactive table. It can run on any size hardware. So if you wanted to run it on a multi-touch surface that covers a whole wall, then that's fine, that the software scales up to that. And by having all of your different devices running this platform, it means that you get the seamless transfer of information where you can flick information off the edge from one table to another. If you're running the app on your iPad, it enables you to send and receive things quite easily. The platform is designed to enable people to write their own apps, and we'll have a demo of this afterwards where I can show you through some of those. And there are also many applications for education, but also in other industries as well. And it comes with a content management system so that a teacher could put together a set of materials for students to work through at the table. So in education, some of the most obvious uses of that might be putting together a information kiosk in a place like a museum for students to browse through and learn about the collections of a museum. Also in brainstorming use, we have applications for that where students could be writing down notes on a topic. They could be using physical keyboards, which enables them to type very fast without having to worry about typing on a touchscreen. And then they could be pulling those ideas into the middle of the table, organising them into groups, and then talking about the emerging themes. And it can also be used as a discussion table for information collected on other devices. So if people are coming in with information that they've got on their smartphones, which might be the case in a museum, and I'll talk about a case study that's explored doing that, where people can tour around the museum, collect information, and then brainstorm around a multi-touch table at the end. So I've got a short video which just shows a few of the different ways that the software can work. We've also got a few more on our website, which I'll give you a link to at the end of this. If I can get my mouse cursor, we can press that video. Yep. I'm Anthony Collins. I'm the product leader of interactive surfaces at Services CRC, and we've developed a connected surfaces platform which enables new dimensions of collaboration on interactive surfaces. The Connected Surfaces platform is designed to bring a new dimension to collaboration where walls and tables can become interactive surfaces to support group collaboration in many domains such as education, workplace training, retail and marketing, and also in defence strategy, for example. The platform enables a small group of people to collaborate around a shared workspace, and that enables many new applications for group collaboration. So that could be from teams brainstorming to perhaps educational training sessions that people can conduct around a shared workspace. But they're typically used in this kind of configuration where it's used as a presentation tool for the teacher, used for web browsing and PowerPoint presentations. Our technology brings a new element to that where information can actually be transferred seamlessly to any of the devices in the room. So the teacher can be throwing information off onto the students' tablet devices, and they can be contributing and answering questions and sending information back to the teacher onto the whiteboard. Information can also be thrown off to any of the other devices in the room, such as extra tabletops or interactive displays. One particular area that we've been working with partners like the Australian Museum, where we've been looking at how to breathe new life into their education programs with visiting school groups. In one example application, we have students touring around the galleries, capturing information on their tablets, such as photos, sound clips, and notes. And then they're able to come to a shared tabletop workspace, present that information as a group, and brainstorm about themes set by the teacher. And then at the end of the session, they can save that and take that back to the classroom. So just at the end of that video, it briefly mentioned some work we've done with the Australian Museum. And I'm running short on time, but I'll very quickly give you an overview just on the work that we did there. Through our research project, we wanted to study new education applications for this kind of technology. We worked with the Australian Museum Learning Services Group, who had some existing devices like interactive whiteboards, and they were also going to get a bunch of iPads as well, and they wanted to explore how they could bring those together so that they could have an activity that was not particularly structured, one that could that was based on giving out the iPads to the students and then letting them have free roam on a particular gallery, collecting information about a particular topic set by the teacher. And then at the end of that, the teacher and the instructors would actually conduct a brainstorming session and a poster creation session after they come back into the learning services room. So the students would go out with iPads. The museum had a cart full of those that they provided. Usually the iPads were shared between students. And that also meant that while the students were out and about in the gallery, they were also talking to each other, so it wasn't a completely individual activity. And then at the end of that, we had a multi-touch table and also an interactive whiteboard, and the students were tasked with creating posters on the information collected. For example, in one group, they had to collect information on a certain predator, and they also then had to collect the corresponding information about their prey. So when they created the poster, they had to answer some themes set by the teacher, and that poster could be saved and taken back to the classroom for further learning. And we actually did this as part of a formal study where we're looking at the usability of the software, but also comparing them doing that poster creation at an interactive table and also at a whiteboard. And we found some really interesting results about how to improve the software to cater for that, such as adding support for scripting or orchestration into the activity at the table so that the teacher could define stages of the activity that the students have to follow, and that the software could actually cater for that, so that when the teacher is moving around to all of the different groups, the software can actually be guiding the students rather than requiring the teacher to keep an eye on every group as they're doing the activity. In terms of the future, we have the ongoing research at Sydney University that's feeding into the commercial product that we're offering. Some of the work that's happening there is capturing speech and gesture information at the table so that we can use data mining techniques on that to offer feedback to the teacher and the learners about who's doing what in the collaboration. So by taking something like a multi-touch table and adding a microphone array to it and also a overhead camera, we can track who's doing all the talking, who's touching all of the things on the table, and we can provide graphs and live visualizations to the teachers about which students are doing all of the work in the group or which ones haven't contributed. And that information can be presented on a dashboard interface for the teacher that they can have while they're walking around assisting different groups in the classroom. And that dashboard also supports the orchestration of the activities, such as locking out the tabletops to force the students to actually listen to the teacher. So in terms of thinking about what a classroom would look like with lots of these tables, it's certainly clear that we need to support the teacher managing and forcing the students to listen when they need to. And there's also a lot of other research on large display interaction, so creating immersive walls, projecting on really large surfaces and using gesture control, which we've used in advertising, but it also has relevance in education too. And also lots of research on new gestures and interaction techniques to make it very straightforward to use the software. So that's about it. We've got more information on the platform on our website, but we've also got a demonstration set up here along with the iSee technology. So at the end, I encourage you to come and chat with me if you're interested in it. We're also planning to put in a Commercialisation Australia proof of study grant application where we'd like to establish some connected classrooms where they'd be made up of multiple multi-touch surfaces in the room as well as interactive whiteboards. And we'd like to study how they're used in practice and what kinds of software support we need to make that a reality. So if you're interested both from an educator perspective or even from a technology perspective, we're looking for some pilot schools to deploy the technology. And also we'd be teaming up with some hardware manufacturers to hopefully donate the technology for the schools as well, just so that we can study this a bit better. So that's it for me. Thank you for your time.